let's not waste any time. Let's jump straight in. With it being Tuesday, it is paper 2 day. So I wanted to do some more questions on circle analytical geometry with you. As always, I have tried to find more challenging questions to do with you guys. So I hope that these will provide a sufficient challenge to you. Okay, so question number 3 says, in the diagram with circle center M, 5 and 4 touches the y-axis at N and intersects the x-axis at A and B. PBL, so sorry if I just move this down a little bit, PBL and SKL are tangents to the circle where SKL is parallel to the x-axis and P and S are points on the y-axis. LM is drawn. Okay, let's have a look at the questions associated with this diagram. I'm just going to try and move that over a little bit. In fact, sorry, I don't have my mouse here today, which really annoys me to say the least. Oh, I actually managed to do it. Okay, because I want us to be able to see how much the questions are out of while we attempt them as well. All right, so the first question asks us to write down the length of the radius of the circle having center M. The length of the radius. So this is a question, it's an easy question, but if you don't know what to look at, it can actually be a little bit tricky. So what is the length of the radius? What's the length of the radius? What do you guys think? What's the length of the radius? So it's got to be here in the information that's been provided to us. We don't have the equation of the circle, so we can't get it from there. Okay, so Pumi says it's 4 units. Jamie says it's 5 units. Okay, so we've got 2 different answers. What do we think? Now Pumi's changed their mind. They've said 5. Keith Lynn reckons 5. Okay. All right. Can anybody, ooh, what is that? Sorry, I clicked on something weird. Okay. Who's the first person who said 5? Was Jamie, I think it was. Jamie, why 5? Are you happy to tell us why you said 5? Don't be shy, Jamie. Don't know if Jamie's typing or if Jamie's just hoping that I hadn't called on them to answer the question. But anyway, let's move on, Jamie. I'll let you off the hook. For everybody else, the reason why it's 5 and not 4. All right, and I think it was Pumi. Pumi, don't feel bad about your answer here. I'm very pleased that you were willing to participate and offer an answer. If you think about what an X coordinate and a Y coordinate really represent, then it helps us to understand how to work out an answer. So your X coordinate tells you how far the point is from the Y axis. Okay, so it's 5 units to the right of the Y axis. The Y coordinate tells us how far the point is from the x-axis. So the 5 is correct here because it is 5 units from N to M. It's 4 units from this unknown point over here. Sorry, I beg your pardon. It's not 4 units from it. It's 4 units from the x-axis to m. Okay, so this vertical line over here is not a radius because it doesn't go to the outside of the circle, whereas nm does. Okay, so that's why the length of the radius in this case is 5 units. I hope that makes sense to everybody. Okay, so yes, r was equal to 5. Boom, there we go. Now they want us to write down the equation of a circle having m, center m, in the form da 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 da. All right, so if we have been given the coordinates at the center, it's very easy. And we know the length of the radius, so we know what r squared is. So this would be x minus 5 squared plus y minus 4 squared equals r squared. So that would be 25. Okay, so we would have another mark over there. Now they want us to calculate the coordinates of A. A represents an x-intercept. Okay, so they told us here that the circle with center M intersects the x-axis at A. So for an x-intercept, we would let y be equal to 0. So we would have x minus 5 squared plus 0 minus 4 squared is equal to 25. Yes, Wanaka. All right, because your x-coordinate tells you how far the point is from the y-axis. Okay, so from m to n, that is the radius. Okay, so with n being on the y-axis, that's what's important here. Okay, your y-coordinate tells you how far the point is away from the y-axis. So the distance nm is your radius. Okay, so we can't use the distance formula for which question, Pumi? For which question did you want to use the distance formula? You mean when it said to you write down the length of the radius? 3.3. Oh, the question that we're on at the moment. No, because in Pumi, they want us to, I suppose we could, because what we could do is, we could, yes, I suppose we could do that. That would be an alternative way of doing it for me. You know what the length of the radius is. So you know that at A, your y coordinate would be 0. So yes, that's another way of doing it. So if you use distance, but it would give you would end up with a very similar thing to this. So distance would be 5 equals, and then in your root over here, you don't know what your x-coordinate at A is, minus 5 squared plus, then your y-coordinate, so this would be 0. Can you see it would end up being exactly the same thing? It's just a different way of setting it out. And then you would square both sides. You'd end up with exactly what you've got here anyway. Okay, so have you guys realized by now that this formula, x minus a squared plus y minus b squared equals r squared, that is distance formula? Okay, it's just been squared on both sides. And that's because a circle is defined by a central point, and then all the other points that are on the circumference are the same distance from that point. That's why distance formula actually describes the equation of a circle. Okay. Yeah, and then of course you'd have to multiply everything out. Don't forget, when you square your binomial, you've got to have 3 terms. So it would be x squared minus 10x plus 25 plus 16 minus 25 equals 0. So that would give us x squared minus 10x plus 16 equals 0. And then when we factorize, we'd end up with x minus 8 times x minus 2. So therefore, x would be equal to 8, or x would be equal to 2. All right, so we would choose 2. So at A, x would be equal to 2. So therefore, the coordinates of A would be 2 and 0. Okay, that was out of 3 marks. A mark for making y equal to 0. Probably a mark on our factors. And then choosing that A would be 2 rather than 8. Okay, so the coordinates at B must be 8 and 0. Okay, oh, and look at that. It says to us, if the coordinates of B are 8 and 0, calculate the gradient of MB. So that's easy. That's not a difficult question. So in 3.4.1, the gradient of MB would be 4 minus 0 over 5 minus 8. So that would give us 4 over -3. Okay, so 1 mark for subbing in, 1 mark for your answer. Then in 3.4.2, they want us to determine or calculate the equation of the tangent PB in the form y equals mx plus c. So what are they looking for here for us to get started on this question? How would we calculate the gradient of the tangent? How would we calculate the gradient of our tangent? Okay, so we've got the gradient of MB. All right, so Chad says it would be 3 over 4. Yes, why is that though, Chad? We've got to explain why that is. Because there's going to be a mark in those 3 marks awarded to that. What is the reason that the gradient is 3 over 4? Exactly. Okay, so the gradients multiplied together must equal -1 because the gradient of the, the radius is perpendicular to the tangent. Okay, so MB is perpendicular to your tangent PB. Okay, because the radius is perpendicular to a tangent. Okay, so the product of their gradients is -1. So therefore, 4 over 3 times the gradient of your tangent equals -1. Let's just move down. So therefore, the gradient of PB is going to be 3 over 4. All right, and now to calculate the equation, what point are we going to sub in? Now that we've got the gradient, what point would we sub into y equals mx plus c to work out the value of that c? Point B. Okay, so Chad's got an answer already. Okay, Chad, let's just catch up to you a little bit. We would sub in point B, which has the coordinates 8 and 0. So it would be 0 equals 3 over 4. Our x coordinate is 8 plus c. Let's just go down a little bit. So that means that c would be equal to -6. Okay, is that what you said, Chad? 3 over 4x minus 6 out of 3 marks. Okay, so radius perpendicular to tangent. We've got our gradient. We've got our y-intercept. Okay. Next question. Write down the equation of tangent SKL. Right, so I want to see, ooh, sorry guys. What on earth did I do? Sorry, clicked on something funny. How are we going to determine the equation of tangent SKL? I want to see what you guys have to say about this rather than me telling you the answer. What do you guys think? Okay, so Chad says y equals x equals 8. Did one of those mean to be a plus or a minus, Chad? I will say another thing. Okay, so Chad says y equals x plus 8. Pumi says we could find the gradient of km, then find the gradient of kl. All right, but the equation of the tangent, I think what you guys are doing is okay, Jamie, all right, you're on the right track. Why is the gradient of tangent SKL equal to 0? Yes, for me. Okay, and that is because they told us somewhere up here that I know it's difficult when it's not in front of you. Remember, SKL is parallel to the x-axis. Remember, they told us that in the beginning. So yes, Jamie, you are right. The gradient of SKL is 0. So we don't need to find it in the form y equals mx plus c. Okay, I'm going to just be quiet now and let you guys think a little bit more. So sorry, I can't help myself. Okay. All right, Chad, you're almost right, Chad. You're very close. All right, that's okay. Jamie's saying the same thing. Okay. All right. So now you're all saying the same thing. So there's got to be a reason for that. Okay. So a few people have sent through this answer. Okay. Y equals 8. And you are very, very close, but you're not 100% correct. Why are you choosing 8? Where does the 8 come from? Where do you get 8 from? Can you tell me? And then I'll tell you why it isn't 8. Can you tell me why you've said 8? Yes, in Belentle, any line that is parallel to the x-axis will always have a gradient of 0. Aha, because the radius is 5. Lovely. Okay. Now, Chad and everybody else, if you now are talking about going this way, right? Now, you know that this has to be a 90-degree corner, right? Because the radius is perpendicular to the tangent. So you're going straight up. So this line over here is parallel to the y-axis, and this line over here is parallel to the x-axis. You have gone 4 units up. Have you gone 4 units up from 5? Or have you gone 4 units up from 4? sorry, I'm talking nonsense. You haven't gone 4 units up. The length of the radius, I beg your pardon. Remember we said the length of the radius was 5. So are you adding 5 onto 5, or are you adding 5 onto 4? Okay, so you were correct the first time. Oh no, it wasn't you. Okay, so that was Seth, Chad. Okay, I understand why. Okay, so both Chad and Pumi are saying the same thing. Okay, so let's just go back to what we were saying earlier. Remember, your x coordinate tells you how far your point is away from the y axis. So now you are doing the opposite. You're not talking about a horizontal distance. You're talking about a vertical distance. So you were supposed to add the 5 onto the 4, not the 5 onto the 5. Okay, it's not a horizontal distance, it's a vertical distance. Right, so the equation of tangent SKL, it's actually the line y equals 9. Okay, noted. All right, cool. All right, I'm glad that I could help you guys with that. Okay, question 3.6. Show that L is the point 20 and 9. Okay, so like with all questions that say show that, we're not allowed to use the information that we have been given. All right, we've got to arrive at these answers in a different way. And it's obviously not worth a lot of marks. It's only out of 2. So we've got SKL is a tangent to the circle, and we know that it is SKL is the line y equals -9. How are we going to show that the x coordinate is 20? Sorry, Chad, I'm just reading what you've said. Let PML equal scale because they intersect. Okay, but unfortunately, those two will not be equal to one another because SKL is a horizontal line and PBL is a slanted line. So PBL would be longer. I can think of one way to answer this question, but I'm just trying to think if there's a quicker way for us to be able to answer it. That's how I think I would do it rather. Okay, so I was thinking that LK equals LB because they're tangents from the same point, and then using distance formula, but it's only out of 2 marks. So there's got to be a quicker way for us to be able to do this. All right. So we know that at S, what would the coordinates be at S? The coordinates at S would be 0 and 9, right? The coordinates, so this is 5 units long. The coordinates at K, actually, does that help us? Just trying to think whether it did or not. The coordinates at K would be 5 and 9. Sorry, I suddenly thought I was onto something there, but now all of a sudden I don't think I was. Sorry guys, I'm just thinking. It's only out of 2 marks. I don't think so. I'm going sort of back, Keithlin, to what I was thinking in the beginning, which is tangents from the same point. It's just so little marks. I was just questioning whether that was actually the right way to do it. We know the length of SK is 5. I was thinking maybe the theorem of Pythagoras, but I mean, we're talking about coordinates now, aren't we? So I was thinking if we could take SK and add KL, if we knew what KL was. But we don't. Okay, all right. So let's do a tangents from the same point. Maybe there is a quicker way if anybody else can think of something that would be better. So KL equals LB because they are tangents from the same point. So therefore, the length of LB is going to be, remember the coordinates at, oh no, but hang on, we can't do that. Hang on. Because then we're using those coordinates. Oh, I feel so silly now. All right, then there must be another way for us to be able to do this. You were saying gradient. Okay, all right, so we know, so Keithlin, let's just go with what you were saying. We know that the gradient of line SKL is equal to 0, right? So we know that at K and L, maybe you're right, Keithlin. So we've got the y coordinate at L minus the y coordinate at K over the x coordinate at L minus the x coordinate at K. All right, so the y coordinate at L we know is 9. We can sub that in. What we're trying to prove here really is the 20, isn't it? The y coordinate at K, remember initially we were talking about the coordinates at that point. So our x coordinate would be 5, our y coordinate would be 9, wouldn't it? So that would be 9 minus 9 over our y coordinate, sorry, our x coordinate at L. We don't know. No, but you see, then when we cross multiply with 0, so gradient is not going to help us. I feel very silly right now. There must be something very simple here. We know the length of this line is 5. From S to K is 5 units. How can we work out the length of K to L? What do we have? We've got the equation. Hang on a second. The equation of the tangent PB. So PB goes through L. Maybe we can use that. Okay, so the equation of PB was y equals 3 over 4x minus 9. So y equals 3 over 4x minus 9. We know that the y coordinate at L is equal to 9, right? So if we take 9 and we sub it in there, let's solve for the x coordinates. We're going to take that 9 over to the other side. So that would give us 18 is equal to 3 over 4x. So let's times both sides by 4. That would give us 72 is equal to 3x. That doesn't work, does it? Why doesn't that work? No, but that is right, because L is a point of intersection. So between the line y equals 9, did we have this done minus 6? Ach, because I'm a twit. Look here, guys. Sorry. This is minus 6. That's right. Now it'll be. I'm so silly. There we go. That's perfect. Okay. So L is a point of intersection. It's a point of intersection between the line y equals 9 and line PB. All right, so I'm solving simultaneously here. Does that make sense to everybody? Okay, so we're solving simultaneously the line y equals 9 and the equation of PB, which was y equals 3 over 4x minus 6. So I'm subbing in my 9. I'm going to take that over to the other side. So 15 is equal to 3 over 4x. And that would leave us with 60 equals 3x, so therefore x would be equal to 20. Therefore, the coordinates at L would be 20 and 9. Sorry, silly me. Okay, everybody happy with that? Sorry, I don't know why I was being so silly. I was thinking of all sorts of other things, but not. All right. So again, I suppose because this is just so well practiced in me, is that whenever I get to something like that and I think to myself, I think of like a way to be able to do something, and then I try it and it doesn't work. I always end up going back and saying to myself, what information do I already have that can help me? And I'm silly, I should have started there. I know that this is the line y equals 9. I know the equation of this line, L is a point of intersection. Yes, you were, Chad. Perfect. That's exactly what you would, that's what I was doing over here. Okay, perfect. All right, now they want us to calculate the length of ML in third form. So the distance of ML. So subbing into distance formula, we now know that the coordinates at L are 20 and 9. So we could say here 20 minus 5 squared plus 9 minus 4 squared. Sorry, I'm kind of squeezing this in. The length of ML would be I'm getting 5 root 10. Are you guys getting the same answer? 5 root 10. Okay, so 1 mark for making them equal. And then I suppose a mark there. In third form, 1 mark for subbing in, 1 mark for our answer. Okay, now on to question 3.8. They want us to determine the equation of the circle passing through points K, L, M in the form x minus p squared plus y minus q squared equals c squared. Good, so now we've got a little bit of a more difficult question. Right, it passes through K and L and M. All right, so I want you guys to look at the diagram and I want you to give me some ideas as to how you think we would start to answer this question. What I've got on the diagram should give you some good hints. So you're looking at K, L, and M. and the circle needs to pass through those points. So K and L and M are on the circumference of this circle that's not drawn. What do you think we should do here? Katleho, go for it.
Hi, ma'am.
Hi,
Ma'am,
Katleho.
aren't we supposed to find the, what's this? The midpoint. No, the center of the circle, ma'am, by
Yes,
using these two coordinates.
yes. So now, what line is important in this situation that's going to help you find the coordinates at the center? Oh, Jamie's put it on the group. What were you going to say, Katleho?
Ma'am, I was going to say LM.
You're right. You're quite right. Well done, Katleho. That's perfect. Okay, so Katleho is perfectly right and Jamie is correct. Okay, remember, you have a right angle over here at K. Because you have this right angle at K, it means that ML has to be the diameter of this particular circle. You know that the diameter passes through the center of the circle. Okay, and half the diameter will give you 1 radius. So that means that you can find the coordinates at the midpoint of ML. They would be the coordinates at the center of the circle. And the length of, I mean, if I called this point, let's choose a letter that's not on our diagram. Let's choose the letter F, for example. So F is the midpoint of ML. You know that MF would be a radius or FL would be a radius. And then you could calculate the value of R squared. Okay, so good thinking there from Katleho and from, was it Jamie or Chad? I can't remember who shared their answer. Oh, it was Jamie. Okay, good thinking, Katleho and Jamie. Okay, so let's go ahead and go and do that. So what do we need to establish in order to be able to answer this question? Well, first of all, that ML is the diameter of the circle. So over here, 3.8, ML is the diameter of circle KLM. Okay, and the reason that ML is the diameter of circle KLM is because there is a right angle at K. All right, so that would be converse angle in a semicircle. I'm just trying to think, I should have explained why K angle MKL was equal to 90. Oh, okay, so MKL would be equal to 90. So because the radius is perpendicular to the tangent, so radius MK. So ML is the diameter of the circle, converse angle in a semicircle. So therefore, the midpoint of ML is the center of the circle. All right, so now calculating the coordinates at the midpoint, we've decided to call it F. That would be 5 plus 20 divided by 2 and 4 plus 9. 4 plus 9 divided by 2. Oopsie. So therefore, the coordinates at F, come pen, is going to be 25 over 2, and this would be 13 over 2. So therefore, you'd have x minus 25 over 2 squared plus y minus 13 over 2 squared is equal to r squared. And you could use either the coordinates at K or the coordinates at M or the coordinates at L in order to be able to solve for R. Or you could work out the distance from M to F or F to L. That would also give you the coordinates of R. I think it's probably just easier to sub in a point. So I'm going to sub in 5 and 4. Okay. And sorry, I've lost my mouse now. Oh, there it is. And now let's put in 5 minus 25 over 2 squared plus 4 minus 13 over 2 squared equals r squared. So therefore r squared would be equal to, sorry, Chad, I see you sent me an answer. Okay, I'm getting 125 over 2. So it would be x minus 25 over 2 squared plus y minus 13 over 2 squared equals 125 over 2. Oh, sorry, Chad's saying I made a mistake. Let me just see. What did I do wrong? Chad, you saying that I used the wrong... Oh, okay. All right. I was just going back and having a look. I didn't understand what I had done wrong there. Okay. All right. So Swanaka, what don't you understand? Can you be specific? It would be one way of doing it in Balendle. You should get the same answer. So whether you sub in one of the points on the circumference, or whether you calculate the distance of MF or the distance of FL, it's going to be exactly the same answer in Balendle. Okay, so there'd be more than one way of being able to do that. Okay, so what's important in this question is to establish what Katlego was trying to say. all right, is that ML is the diameter of the circle. That is the critical thing here. And the reason that it's the diameter of the circle is because it's opposite an angle that is 90 degrees. Okay, so converse angle of a semicircle proves that ML is the diameter of the circle. Okay, if ML is the diameter, then MF and FL will be radii. Okay, so calculating the coordinates of F, we're going to use midpoint formula, and then F represents the center of our circle. And then we can go and sub into the equation of a circle, sub in one of the points that lies on the circle, and solve for r squared. Okay, so that was out of 5. So definitely a mark for calculate or for stating that ML was the diameter of the circle, using midpoint formula to get the coordinates of F, subbing those in here, subbing in another point. How many marks we've got now? 1, 2, 3, 4, and then the last mark would be on the answer. Okay, does that make sense to everybody? We all good? Teeth done you fine. Okay. Mosey, you fine. All right. Cool. So we don't have an awful lot. Oh, now it makes sense. Okay, Zwanaka. Okay, so what was important there was establishing that ML was the diameter of the circle. Once you've done that, the rest of it is just the same old subbing in, well, determining the coordinates using midpoint formula, subbing it in, and then working out the length of the radius by subbing another point on the circle. Okay, so I don't know if that's a particularly difficult question. I don't think it's the sort of hardest problem solving question they could give us. But there we go. Okay, let's see what else we can do before our time is up. I think, let's just see, I think I've got another, oh no, that was the other question. All right, let's have a look at this question. We'll see how far we can get with this. All right, what I'm going to do is I'm going to let you guys try. Probably should be able to do all of these actually quite easily. 4.1.1. Let's see you guys do that yourselves, and then you can share your answers with Yolanda and I. Let's start there. Yolanda, just give me a second. I'm just going to get something for my arm. Just hold on a moment. I'll be 2 seconds.
No problem.
I literally was 2 seconds, wasn't I?
Like legitly 2 seconds.
Sorry, it feels like something stung me on my arm here, and it's been bothering me while we've been sitting here. I just want to put some muti on myself.
Yeah. So.
Okay. Anyone got the equation of the circle so far? Okay, so Chad sent me an answer. That's correct, Chad. Let's see what everybody else is saying. Good stuff. Okay, Chad, you can try 412 now. Good, Mbalenhle. That's lovely. Well done. Good job. So yeah, DM your answers, guys. No, Mbali, you are correct. That's good. Lesedi, beautiful. Well done. Very nice. So all four of you sending through perfect answers. Excellent. Well done. Try the next question. Okay, so Mozi, you don't have to square root the radius. Remember, you want r squared. Okay, so on the right-hand side of your equation, it's not the square root of that value, it's just the value you set. Okay. Good, Jamie. Your answer's also correct. Cool. Mbalenhle sent through the coordinates of D already. Mbalenhle, that is correct. Good. Well done, Mbalenhle. Nice. So Mbalenhle, go on to question 4.1.3. Okay, Chad, I'm just writing down your answer quickly and just checking if that's correct. Yeah, that's okay. I was also just checking your answer. Yeah, that's not correct. Chad, just check that again. Good, Mbali. Good, Jamie. Yes, well done. Those are good answers for question 4.1.2. You getting there? Nice job. That's it, Mbalenhle. There you go, Chad. You've got it now. Okay, you and Mbalenhle are like neck and neck here. Brilliant. Well done to both of you. Perfect. Good job. Okay, so that gives you 10 marks out of 22. Okay, all perfect. Good, good, good. Well done. Let's see if you can do E, the coordinates of E and 4.1.5 before. I suppose this show that question is always going to be a little bit more difficult. Okay, so, all right. So Avio and Keithlin, you've both got your brackets with the X in it and your bracket with the Y in it correct. But Keithlin, there's not supposed to be a root over that number. Remember what's on the right-hand side is R squared. Okay. Avio, you've got the wrong value there. So can you explain to me, Avio, where did you get 5 from? So, Avio, the best way for you to do question 4.1.1. So what you did here where you said x minus 2 squared plus y minus 4 squared, that was perfect. Now, when you want to calculate the value of r squared of Avio, sub in the other point that the circle goes to, which is point C. So your x is minus 1 and your y is 2. So now when you work out the value of r squared, are you still going to get 5? Okay. So, Lesedi, let's just have a look. Yes, Lesedi, that's correct. Good. Bali, I just want to go down to your answer now. Highball, why is it not going down? Yes, correct, Keithlin. Okay, so on the right, because remember, you're not trying to solve for R. Okay, that's quite a common mistake amongst matrics. Okay, so it
Wow.
would just, yeah, it would just be that value. Okay.
Can I run
Right.
the poll or not?
Shame, I think they're just sort of finishing off. I was just giving a bit of
Okay.
feedback. Yes, run the poll by all means.
Okay.
Okay, Mbali, that's not the correct answer. Yes, Chad, perfect. Please do the poll. And before you go, I will show you the answers. Ach, Jereman. Sorry, guys. Has everyone answered your poll?
Not yet.
Not
Getting
yet.
there. But I think you can continue as they answer. I think it's fine.
Okay. Yes, Avio it is. Perfect. Well done. Correct, Mosey. Okay, so I know trying to sort of squeeze all of this in at the end. Question 4.2 is a nice sort of, it's actually a separate question altogether. We should definitely do that the next time. I just want to show you here what the answers to this question should be. Okay, just in case you were wondering. Okay, so in 4.1.1, that's this answer over here up at the top. So x minus 2 squared plus y minus 4 squared equals 13 was correct. The coordinates of D were 5 and 6, as so many of you said. The equation of AB is over here on the left-hand side, question 4.1.3. So the equation of AB ended up being y equals minus 3 over 2x plus a half. Okay, then calculating the coordinates of E. E was the y-intercept. So for the y-intercept, you're going to make x equal to 0. So you should have got 7 or 1. And you should have worked out that at E, it would be 0 and 7. That's it, Mosey. That's quite right, Chad. Okay, so because the lines are perpendicular to 1, perpendicular, the product of their gradients would be -1. And then in the last question where you had to show that EM was parallel to AB, we had to calculate the gradient of EM, which was also 3/-2. So the gradients are the same, therefore the lines were parallel. So you guys are welcome to take screenshots